faculty student development program on data analytics using R. We are happy to inform you that Professor P. Suresh Varma garu, former Vice Chancellor Adikavi Nannaya University, for accepting to be the orator of this program. I request now our Principal Dr. M. Ramji garu to give his message for the day.
Thank you, Sri Ravindra Babu. Good morning to you all. First of all, I want to extend my sincere thanks to Dr. Suresh Varma, former Vice Chancellor, Adikavi Nannaya University. Sir, we are really grateful to you because when we asked over phone itself, you accepted to address the academic community. And we all know that computer field is such a field that every day it is a changing field. If we do not equip ourselves, maybe within 2-3 days,
connect avaddu home connect avaddu
community. So I hope that this lecture will be gives additional information and knowledge to all of us. Once again, I am sincerely thanking Dr. Suresh Varma for his kind acceptance. One thing I want to tell Dr. Suresh Varma here in our Sanketika Vidya Parishad Engineering College, Visakhapatnam, I am very happy to inform you that last year, almost all BTech final year projects were published in UGC recognized journals. And this year also, around 6-7 papers were published. This may be a record, definitely in India, because an ordinary private engineering college publishing in UGC recognized journals, maybe our first college, and we are repeating this year also. And you know that we are initiating to publish an international journal, and we are also thankful to you for accepting to be the editor of one of the editorial board of that journal, and we are trying our best to bring it on 23rd of this month. If not, maybe within less than a week's time. But we are confident that we can bring it on 23rd. So with these few remarks, once again, I'm extending my sincere thanks to Varma and welcoming each and everybody who are directly or indirectly participating in this webinar. Thank you. All the best. Over to Dr. Suresh Varma.
Sir,
very good. Chavan, sir.
Thank you, Principal Garu, Dr. Ramji Garu, for giving the message for the day. Now it's my pleasure, privilege to introduce Professor P. Suresh Varma garu. Professor P. Suresh Varma garu served as former Vice Chancellor and Rector, Adikavi Nannaya University, a senior-most professor in the university. He currently holds the position of Dean, Faculty, Engineering and Technology. He has also served the university in other capacities, which include Executive Council Member, Senate Member, Dean College of Development Council, Dean IT, Dean Faculty of Engineering and Technology, and Chairman Board of Studies in Computer Science and Engineering Department, Adikavi Nannaya University. He has also served university as Principal, College of Engineering from 2014 to 17. And prior to Adikavi Nannaya University, Professor Varma garu worked in various organizations like Geetham, GMRIT, Vignan IIT, Dr. LB College in between 1994 to 2008. His research includes computer networks, cloud computing, image processing, and data analytics. He has bagged awards also, like Best Teacher Award from Government of Andhra Pradesh 2010, and university has awarded him with Best Researcher and during the University Convocation 2018. Apart from being a member in various editorials like IJCAIT, JISC, CIJE, and AJCIST, he is also a fellow of IETE and IE. He is also a member in various other professional bodies like IISA, APSMS, IAOE, ISRS, etc. Now I request Professor P. Suresh Varma garu to take over the session. Sir, please.
Very good morning to all. First, I thank to the Secretary and Correspondent Chief Patron Ravindra Babu garu and Principal of Sanketika Vidya Parishad Engineering College Professor Ramji garu and Convener Suraj Kumar garu and Krishna Kumar garu and technical expert Sai garu. I am very much thankful to all the organizers for giving me an opportunity to deliver lecture under your college brand. And I have a lot of long association with Ramji garu because long back he is my classmate also. So once again I thanks to the Professor Ramji garu for organizing this one-day faculty development program. Now I am starting the data analytics using R programming. So the first time giving a here Sir, first of all, I think everyone you are seeing the PowerPoint presentation. I think someone have to respond because you are getting the screen or not. Can I start these things directly? So now I'm starting here. Data analytics. Data analytics using R programming. So first, everyone have to know there is a lot of definitions for the data analytics. So as per Wikipedia, data analytics is the process of inspecting, cleaning, transforming, and modeling data with the goal of recovering useful information, suggesting conclusions, and supporting decision making. And another definition, leverage data in a particular functional process to enable the context-specific insight that is acceptable. Data analytic capabilities. So nowadays, we are seeing the buzzword data science. And the total industry and academics and in all aspects, everyone we are concentrating on the data science. Once if you want to study the data science, basically we need to study the data analysis, data analytics, next the machine learning. So data analytic capabilities, we are divided into 4 categories. One is the descriptive analytics. So that is with the existing data, what happens we'll observe here. And the next is the diagnostic analytics. This is nothing but analysis why did it happen, and we will study in this phase. And in the predictive analytics, what will happen the for third phase. And now in the data science concept, how can we make it happen, that is for the future purpose. This is from what happened to what will happen. And this data analytics, we are divided into various pillars. To understand or to expertise in the analytics, we require three pillars. One is the people and the process and the technology. Once these pillars, the basic pillars of the analytics. So data analytics architecture, we are talking about the information technology. From 1980, once the personal computer SURESH concept came, we are generating huge data, and we are talking about the IT, information technology. That is nothing but data. So we are collecting huge amount of the data, and we are integrating in the data layer. And once the data is available, we are going to the information and knowledge sharing, a translation of the data and cleaning of data. We are processing the data, and we are interpretation and preparation for the analysis. And after the analysis, we are going for the visualization of the data, and we are using this analysis for business purpose. Once we are doing the analysis, we will bring some conclusions, and based on the conclusion, we'll go for the future action. So there is a lot of benefits for the data analytics. The first part is the integrity, the truth of your data. Whenever we are talking about the data, how much data we are collecting, what is the reliability of the data, we'll study here. And next is the quality. Quality is the data of the superior in nature. And gap identification, when we are collecting the data, there is a possibility of some missing data, and some data is not in the proper format, and that will adjust and will create a completeness of the data set. Next is the efficiency, productivity in our practices. Whenever we are doing any industry or business, how to increase the productivity, how to increase the efficiency in your work, that we can do with the data analytics. And the continuous improvement, the progressive advancement of our process. So whenever we are starting or we are doing some business, each and every stage, how to improve our business, we will do with these analytics. And effective, the valuable, and as a leading and lagging and the coincidental indicators we'll use for the effectiveness of the data analytics. And evidence supports and proves our decision making. And main important thing, data analytics refers, there's the techniques to analyze the data to enhance the productivity and the business gain. This is the main definition of the data analytics. Once if we are talking about the data analytics, the entire industry now, they're looking towards a data analysis or data scientist. So once if you talk about the role of the data analysis, first is the collection of the data. Whatever data we want to collect, we'll collect in the various ways from the various sources. So nowadays, we are collecting the data from the conventional methods to latest technologies like using sensors and the real-time data and the satellite data. Like this, so much of data we are collecting from the various sources. Once we are collecting the data, we have to inspect. The analyst will inspect the data, it is the correct or not, or there is any missing values are there, or any inside the data there is any incompatibility or wrong entries are there, that we have to inspect. And in the cleaning process, we have to clean that missing values, and we have to set up that data cleaning in a process. For example, if you have a male and female, two textual classes, instead of male and female, we can give 0 and 1, and we can convert into numerical values for future analysis purpose. We'll transforming the data into proper readable form. Once if you are transforming the data, analyze the data, whatever the data, existing data is there, we'll analyze. For example, once if you have a data of classroom data, so we'll collect the students' data, and after that, based on their heights and age and their marks, we can categorize into various categories. We'll analyze the data. After analyzing, Based on the existing analysis of the data, we'll design a model. This model will make it generalized and will apply to the other aspects also. Based on this modeling, we'll generate a report, we'll create a reports. That reports uses for the future purpose. In any other place, we can use these reports for the decision making and future enhancements. So the data analytics skills are required. For example, if you want to become a data analyst, so just now we have studied the various roles of data analysis. Now the data analysis requires the various skills. So that is the statistics and data cleaning, exploratory data analysis, and data visualization and machine learning. These are the 5 concepts required to become a data analyst. So nowadays, the entire industry is required data scientists. These data scientists, if you want to become any person a data scientist, then the person requires a basic these concepts. Now we are talking about the what is the role of the statistics in data analytics. So data statistics, the basically we are talking about the two types: descriptive statistics and inferential statistics. So descriptive statistics uses the data to provide descriptions of the population, either through numerical calculations or graphs or tables. Here I am taking one example. For example, you take a classroom and the people are with the different heights, and based on the different heights, we'll using statistics, we'll use mean, median, and mode, and all these things. We'll calculate the average height, the highest, tallest person, and shortest person, and we'll divide the various categories. And these we'll use for these criteria we'll use to classify the people in the different stages. So once if you are going to the inferential statistics, it generalizes the large data set and applies the probability to draw a conclusion. It allows us to infer the data parameters based on the statistical model using the simple data. If you take a same classroom, so finally after doing all these statistical methods, we'll come to the conclusion the average height of the classroom as a person is a particular amount, particular size. This same thing we can apply for the other places also. The basic difference of the descriptive statistics and inferential statistics: in the descriptive statistics, concern with the properties of population, and it presents the data in a meaningful manner, and outcomes are shown in the form of charts and tables and graphs, and it describes the known data and measures central tendency and the spread of the data. If you go into the inferential statistics, it makes inferences from the sample and compared and predicts the future outcomes, and outcomes are in the form of probability scores, and tries to make conclusions beyond the data available. And hypothesis testing and analysis of variance. Here we are talking about the 2 important things: descriptive statistics and inferential statistics. In the descriptive statistics, we'll collect the existing data, and using existing data, we'll do the analysis and we'll prepare the charts, tables, and graphs, and we'll describe the known data. And from that known data, we'll calculate the central tendency, spread of the data, distribution, and all these things we'll explain here. And the inferential statistics, once if you observe the existing data, we'll compare with already existing and future, and we'll predict the future outcomes. Outcomes are in the form of probability scores. Whenever we have an existing data, from that existing data, we'll go towards the direction of the prediction and what future outcomes and what conclusions we can make beyond the existing data available, and we'll do the some hypothesis test, and we'll do the analysis of variance, how it is varies and how it is goes to the next predictions. And the second part, once if we are talking about the statistics part in the data analytics, once next is we are going to the data cleaning and manipulation part. In the data cleaning, the process of detecting and correcting corrupt or inaccurate records from the database is said to be data clean. For example, we are collected a small data or huge data. For example, if you take a classroom data, once if you are taking the classroom data, if you forgot to give the details, height details of the certain students, then the table will observe that is the missing data. And sometimes in the data, while you are giving the gender data, male or female, then that is the missing data. And sometimes instead of male and female, if you write the city name, that automatically data is not correct in that column. So these are the things while we are collecting the data and we want to analyze the data, first we have to identify these corrected and inaccurate records, and we have to clean up in a proper method. First we have to identify the missing values and we have to delete that records, or we have to follow a method how to fill the data. Second one, if you have any records, if the incorrect data is entered in a particular column, so that incorrect value we have to remove and you have to fill in a proper way. And another one, whenever you are having a records, just now I told that there's a lot of character data, strings data is available. So if you have a male and female, if for analysis purpose, we can change the data in 0 and 1 format. Or if you have a proper city names, for example, if the 10 cities data if you are collecting, instead of various lengthy city names, we'll give the city code. So based on the coding of that city, we can analyze easily. So these are the various steps we'll follow in the data cleaning process. So once the cleaning process is completed, then we'll go for the process of changing the data to make more organized and easy to read is known as data manipulation. The process of changing data and to make more organized way, what we'll do the cleaning and we'll do the manipulation, so which requires for the future analysis purpose. So once if you are having cleaning and if you are properly organized, then we have to go for the data visualization. So in the data visualization is the represent of data in the form of charts, diagrams, and various ways. In the right side diagram, it shows so the various forms of the data visualization that using programming language and will represent the data in the various forms. Once the data visualization comes into the picture, next important thing, we'll go for the machine learning. There is some algorithms are required. That algorithms will use to give the outcomes or predictions. So machine learning is a concept which allows the machine to learn from examples and experience, and two, without being explicitly programmed. So these are the some machine learning algorithms. So there is a supervised, unsupervised, lot of algorithms are there. Now we are talking about the AI, machine, artificial intelligence, and there is a deep learning, there is a reinforced engineering, there is a lot of concepts are involved for the machine learning. So these are the, just now we discussed about the data analysis requires the following skills: statistics, data cleaning, EDA, data visualization, and machine learning. Once these concepts are familiar, so the person will become a data scientist. So here I am going for the few examples because I don't want to give more theory. So once if you go to the programming, we can understand easily. So data analytics is a process of extract meaningful insights from the data, such as hidden patterns, unknown correlations, market trends, and customer preferences. This is done by studying and analyzing procured data. So here we have to build a model. The model, first we have to discovery and data preparation, model planning, model building, and finally we'll come to the outcome, that is the results. The results of the projects are guided based on the business goals developed in the first phase. So I'm giving one example for the descriptive analytics example. I'm taking everyone, we are using Google Maps. Once if I want to go from your Sanketika Vidyaparshit Engineering College to Arku Valley, immediately I will open the Google Map and I'll find the route. Immediately Google Map is choosing three routes, and it is choosing one recommendation also. So with the help of descriptive analysis, looking into the map, you will get an idea as you what has happened when you want to go to the Arku, and what will happen. And the predictive analytics gives the traffic information and helps you gain insights into what could happen. So automatically when you want to go in a particular route, the Google Map is continuously monitoring the traffic also, and each and every area how traffic will be there. When you choose a particular path, what happens, and how much time it will take, it is giving in the Google Map. So when you wonder what you should be do, and predictive analytics helps you in choosing a navigation route. There's a three routes. It is recommending one route and it is choosing the alternative routes also. A Google is suggested the best. So in the Google Map, first it suggests the best, and the model predicts the best route based on previous data, because there is a lot of previous data is available based on the previous data. So Google predicts the best route based on the previous data, and Google also suggests the alternative routes as the recommendations. So in the descriptive analysis, summarize the capacity of the data, or we seen what is happened, and predictive analytics what would happen, and prescriptive analytics prescribes the solution for the best solution and recommended the solution. It is also that there is some settings also it allows. If you want to allow that avoid tolls, or if you want to avoid traffic, or if you want to avoid if you want to choose a shortest path, there is a various settings also it is providing. Based on that, the Google Maps, it is following a various methods, that is a descriptive and analytics, predictive analytics, and prospective analytics. This is the one example. So we can observe in the Google Maps. Next you come to the R programming. So now up to now we are seeing the general example of the analytics. Now we are using R programming, how to do it, because just if you are thinking that all the faculty, some people they're aware already R programming. That's why I'm not covering all the features of the R programming. What I require, that is only I am discussing in this presentation. So first of all, my first impression on R was it's just a software for statistical computing. But later I realized R was enough provisions to implement data analytics and machine learning algorithm in the fast and simple manner. This is a complete tutorial to learn a data analytics and the machine learning using R. By the end of this tutorial, you will learn a good exposure to build a predictive models for using machine learning or your own. So what is the benefits of R programming? So the style of coding is quite easy. It is open source, no need to pay any subscription charges, and availability of instant access to over 7,800 packages customized for various computational tasks. The community support is overwhelming, and there are the numerous firms to help you out. And it supports the data wrangling and quality plotting and graphing, eye-catching reports, machine learning operations, data wrangling. There is various packages already available: DPLYR, data table, reader packages, and data visualization. So just I am telling how to install R. It is a very easy package. You can go to the Google, you search the R software down, and you can download and you can install. And to start R Studio, simply you see the right side environment. There is 4 windows there: R script, R console, R environment, and graphical output. So first I am telling clearly there is only 4 spaces, 4 sections. R console, this is the area how the output code you run, and also you can run directly, write codes in console, and code entered directly in R console cannot be traced later. This is where R script comes to use. That is, we can use the R console. R script, as the name suggests, you can get the space to write the code, to run these codes. Simply select the lines of code and press Ctrl plus Enter. Alternately, you can click little run button location at the top right corner of R script. And next is the R environment. This space displays the set of external elements added, and this includes a data set, variables, vectors, functions, etc. To check if the data has been loaded properly in R, always look at this area. And finally, in the last section, the graphical output. Whenever you are running the program, the output will display in this section. This page displays the graphs created during exploratory data analysis, not just graphs. You can select the packages, seek help of the embedded R's official documentation, and if you install the packages here in the right side, here the packages option is there. In that packages, you can go and you can install the packages also. There is a various packages useful for the data analytics. I'm showing there is out of 7,800 packages. I have listed some of the most powerful and commonly used packages in predictive modeling in this lecture. Importing data. R offers wide range of packages for importing data available in any format. So the R supports various file formats to import. It's text files, .csv files, .json files, .sql files, etc. To import large files of data quickly, to advisable to install, use data.table, read R MySQL, SQLDF, and JS Online. There's the packages useful to download various data in various formats. Next is the packages useful for the data visualization. R has a built plotting commands as well. They are the good create a simple graphs, but become complex when it comes to the creating advanced graphics. Hence, you should install ggplot2. There is a one package useful for the plotting. Generally, will import more than one graph on a single plot. So 3 graphs or more than 3 graphs. If you want to draw on a single graph, we have to use the ggplot2 package. This is useful. Most of the data analytics will use the ggplot2. And the data manipulation. R has fantastic collection of packages for data manipulation. These packages allows you do the basic and advanced computation quickly. These packages are dplyr, plyr, and tdyr. There is a etc. packages. These are the various packages available. And next is the modeling and machine learning. For modeling, current package in R, the powerful enough to cater every need for creating machine learning model. However, you can install the packages algorithms wise such as random forest, rpart, gbm, etc. So this is the wonderful and usefulness of the R programming. So we no need to write a code for each and everything. Lot of packages available. In that packages, what package we require, which function we want to use, we'll install that package and we'll load into our program and we'll analyze. I'm giving one example for above concepts because now I am completed R programming. We are going to the directly example of data analytics or data analysis. I was taken one example, Big Mart sales prediction. The data you can also download from the GitHub. I downloaded the data and a simple, there is a various columns. In this, you see the total data divided into two parts. That is the predictor variables and the response variable. So in this big data mart, so I'm talking about the response variable, dependent variable. In the data set, the response variable Y is the one which make predictions. In this case, will predict item outlet sale. For example, if you refer the diagram, the last column is the response variable. So each item outlet sales. First, I am giving small explanation of this data. If I am taking a Big Mart sales, you can take any outlet. For example, Walmart or Reliance Fresh or DMART, you can take any one of the data. Generally, we have a item identified, item weight, item fat content, item visibility, item type, and item MRP, and outlet. This is the shop. Various outlets are in the single city. Outlets, I am not giving the area name. I am giving the code. And outlet establishment year, which outlet established in which year, and outlet size, it is a small outlet or medium outlet or high outlet, and outlet location type, in which city, tier 1 city or tier 1 area, or tier 2 area, tier 3, that is in the middle class area, slum area, or posh area, and outlet type. And these are the data we'll collect from the mart. But response variable is a response. We are talking about the dependent variable for all remaining parameters. So based on the item weight, fat content, visibility, MRP, identity, all these factors is the independent variables, and dependent variable is outlet sales. How the sales in each outlet. And predictor variable and independent variable, there is a data set. Predictor variables xi, those using which prediction is made on the response variable. In the figure, we are taking about all the columns. So there is a various columns here we are writing. These are the columns data will take it for predicting this response variable. So here I am giving two important things: train data and test data. So to predictive model always built on the train data set. An intuitive way to identify the train data is what it always has to response variable included. So that is, in the test data, once the model is built, it is accuracy to tested. A test data, the test data is always contains a less number of observations than the train data, and also does not include response variable. So here we are talking about the one mall or one. There is a big mart data we are collected. Once we are collecting the data, I was taken a train data, because first we have to observe how the response variable is responding based on the predictor variables, that is the independent variables. We'll collect all the data as well as the sales of the shops also. That is the train data. Once we have train data, we'll observe each and every mart or outlet sales, how it is coming and how the sales are depending and which variable it is depending. First we have to study. That is the initial stage. We have to take the total data including your existing data and sales also. That is the dependent variable also. But once we are doing some analysis, after that we'll go for the test data. Once in the test data, we'll collect a new data and we'll remove the last dependent variable. And based on the test data, we'll apply what is the model we are designed, and we'll apply test data without including response variable, and we'll calculate how the response variable is coming. Then we'll compare with the train data and test data. What is the accuracy? For example, in the train data, we are included the response variable also. For example, particular outlet this year, we are expected based on the input variables, we got some 70% sales. So next year, so if you how much we are expecting, we'll remove all the prediction data, and based on your existing data, we'll calculate what is the sales we'll expect in the next one. And for expecting, we have to understand in all the columns, independent columns, we have to calculate, and which variable it is depending more. First, we have to study, and that based on that, we have to predict in the next. So here in the R programming, I was giving two important things. First one, once I was downloaded .csv files from GitHub and I store in my hard disk. And next I have to start RStudio, and you have to load two databases. That is there is a read.csv file, train data.csv file, and test equal to read.csv file. test underscore data CSV. These two lines will tell how to load data from hard disk to your RStudio. There's a three-step process. One is directly we can assign, we can download from the internet or from the data source and you store in your hard disk. After that, you load into the your software. And here I'll give one example. So here in the graphical, there is a I will show in the studio later how to include directly. You can import directories, import database, and you can store and you can load into the your RStudio. So once if you load in train data, set data into our environment. Okay, after completing of this, I will show RStudio. If the time permits, we'll execute all the code in our RStudio because with the time is constraints. That's why I've already executed this code in my RStudio and I was copied into the PowerPoint. This everything code is available in PowerPoint. It is an executable code. You can execute, you can copy the slides and you can execute in your RStudio. You can see the output and you can enjoy the predictions and graphs. So here to check the data set has been loaded successfully. Look at our environment section. The data can be seen there. And let's explore the data quickly. And first you check the dimensions. Here I'm using the dim command, dim train, which gives 8,523 and 12. And for train set test dim 5,681 and 11. So which gives these two commands, dim command gives rows and columns of train data set. In the train data set, 8,503 train data set and 5,681 rows and 11 columns in the data set. To check variables and their types of train. So here, next, once if you check it the data, each and every data is loaded or not. We'll check it str train. Immediately, we'll get an output which is shown here. Item identifier. It is in a factor. There is a 1,559 levels, and each one the data how it is appears. If you observe item weight, it is a numerical value. The values are 9.3, 5.92, etc. This shows how the data is organized. Next, see the quick data exploration. First I'll check if this data has any missing values. How to identify the missing values in the given data. So here there is a one command table is NA bracket within brackets train. So we got an output false, true. False is 1,813 and 1,463. In a train data we have seen 1,463 missing values. Let's check the variable in which these values are missing. So may data scientists have repeatedly advised to beginners to pay close attention to missing in data values in data exploration stages. Here I have a command column sums is NA train. Immediately we got a data identifier, data weight, data fact. There is a all zeros except data item weight. So hence we can see the item weight has 1,463 missing values. So this is again we can summarize the train, summary train, you can see the total output. So next is the graphical representation of the variables. Here existing data is there. We can analyze the data in two ways, univariate analysis and bivariate analysis. And the univariate analysis is done with one variable and bivariate analysis is done with the two variables. Univariable analysis is very easy because everyone, if you want to study one column, how it is varying, we already studied in the statistics. For example, if the student height is there, height varies from minimum 0 to maximum height 7 feet or 8 feet, and how it is varies. If you want to do analysis, tallest and shortest and average weight, a single variable analysis you can already do it. But here I am discussing about the bivariate analysis. Let's go now experiment doing bivariate analysis and carve out hidden insights. For visualization, I used the ggplot2 package. These graphs would help to understand the distribution and frequency of the variables in the dataset. So it is a ggplot, the train.aes. Here I am writing x-axis, what I want to write. X-axis is item visibility and y-axis is item outlet sales. And the points we are putting the size of the point 2.5 and the color is a navy blue color. And in the XLab item visibility text, I'm writing what I want to write in the x-axis, what I want to write in the y-axis. These are things I mentioned. And the title also, GG title, item visibility versus item outlet. Here you are seeing x-axis, there is item visibility is available, item outlet sales, item visibility versus item sales. If you draw the GG plot, you can see the right side diagram, how the distribution is taken, item visibility. This is item visibility 0 to 0.3. So you see the item visibility, most of the thing less than 0.2. We see that majority of the sales has been obtained from the products having visibility is less than 0.2. This suggests that item visibility is less than 2 must be an important factor in determining the sales. Let's plot few interesting graphs for exploring such hidden stories. So here, important thing, if you see the database here, item visibility, if you observe 0, then sales are very less. Item outlet sales are very less. If item visibility is 0.01 and it is the 2000 outlet sales, your item visibility is increasing. It is near almost 0.019. This is nearer to 0.2. It is a 4 lakh sales. Like this, there is item visibility directly depending on your sales. So that means what here will do the conclusion. If item visibility increases, because now we got only 0.2, and if increases, then we can increase the sales. And GG plot, if you see, train outlet, identifier outlet sales and bar and identity colors, purple color, and the theme is axis.text.x and x element angle is 70. This is the settings of the chart. And once of you see here we infer that outlet 027 has contributed to the majority of the sales following, and outlet 35 and out 10 is the probably the least footfall. There was contributing the least outlet sales. Here we are seeing outlet 27 and outlet 35. These are the observed 2 is major, and outlet 10 and 19 have a very less sales. So GG plot, again we are writing on this. So item outlet sales with various items. Here we are talking again in the outlet, in the big market, which items and sales are more. We are drawing a graph, GG plot for the various items versus item type. From this graph, we can infer that fruits and vegetables contributes to the highest amount of the outlet sales, followed by snack foods and household products. This information can be represented using block plot chart. The benefit of using block plot is to see the outlet identifier and the mean deviation of corresponding levels of a variable. So here in the graph, we'll see the food and vegetables contributes the highest amount of outlet sales. Next is the snacks and foods. So the benefit of using box plot is that you see outlier on the mean deviation of the corresponding level of variable. So these are the things we are observing. Next graph, I'm talking about the item MRP versus item type. So here GG plot, train is the item type, we are giving MRP. The black point you see the outlier, the midline you see in the box is the mean value of each item type. Here in the middle there is a graph is there, that is the mean value of the item MRP. Item MRP varying from low to high, we are calculating the mean value also. Now we have an idea of the variables and their importance on the response variable. Let's now move back to where we are started, the missing values. Now we will impute the missing value. We saw the variable item weights as missing values. Here we are talking about the missing values. We already derived missing values in the item weight. Item weight is continuous variable. Impute missing values with the mean or median of item weight. These are the most commonly used methods imputing missing value. Here, to adjust the missing values, what we are doing, we are taking about the missing values with the mean and median of item weight. We will take an average and we are doing this. Let's the first combine the data sets. So this will save our time, as we don't need to write a separate codes for train and test data sets. To combine these two data frames, we must make sure that we have equal columns, which are not in the case. Next important thing, we are done the analysis in the different way. Train data, up to now, we are done everything on the train data. Now we have a test data. So after analyzing existing data, first we will take the test data and our outcomes are coming in a proper way or not. How much deviation we have observed for observed value and expected value. This, if you want to calculate, then we have to combine these two data sets. So for data sets, we require same number of columns, but in the test data, we have only 11 columns and train data is at 12 columns. Test data set has one less column, response variable. Let's first add the column. We can give this column any value. An institute approach would be to extract the mean value of sales from train data set and use it as placeholder for test item, outlet and sales. Anyway, it makes it simple for now. I will take a value. Now I will combine the data sets. So here in the R command, test dollar item underscore outlet sales is one column. So I added one column here. In the test data, there is a last outcome sales column is not there. That's why I'm adding for the train data set. Next, I am combine R bind using train and set data and impute a missing value by median. By using median, because it is known to be highly robust to the outliers. Moreover, this problem evaluates the matrix RMSE, which is highly affected by the outliers. Hence, the median is the better in this case. And combine item underscore weight NA, combine item weight less than or medium of item combined weight. So here what I am doing, I am calculating the median and I am filling the missing values. Here the false 14,201. It is important to learn to deal with continuous categorical variables separately in the data set. In other words, there need to special attention. In this data set, we have 3 continuous variables and the rest are the categorical in nature. If you are still confused, I will suggest you once again look at the data set STR and you see the data existence and the data is seeing on the your R Studio or not. Let's take up the item visibility. In the graph above, we see the visibility as 0 value and also which is the practically not feasible. Hence, we consider it is a missing value. Once again, make imputation using median and combine the missing value at the 0 also. I'm again taking the median because I'm showing here graph. In this graph, there is some values at 0 also. This 0 also, I'm using median. I'm adjusting this. So next, let's proceed to the categorical variable now. During exploration, so there is a mismatch in levels of variables which needs to be correlated. Here I am telling little bit, everyone, if you are very new about R programming and very new to the data analytics, so it is little bit complex, but if you take an example and what I am telling, it is really a practical problem. You can take any Walmart data or you can data download from the internet or GitHub site, and you understand stage by stage. You take only 3 or 4 columns and you apply what I am telling. So in a similar way here, I'm not taking huge data now. Huge data is available in this big mart data. I was taking very few. So the trained data and test data. In the trained data, up to now we are doing some analysis, and all the graphs we are seeing here. If you see these graphs, I'm seeing item visibility as versus outlet sales, and outlet identifier versus outlet sales, and what are the items are sales are more, what is influence factor, what is the MRP lower and higher, and after that I'm understood that there is a various. Let us assume that there is 11 columns are existing data. One is outcome or predictor. In this 11 columns, which columns is influencing more on the sales and which columns are not having any effect, that we have to identify, because we have to identify which columns, which data is influencing the output sales. So for that identification only, I am doing all this analysis, a simple case. But what I was done here, first I observed the train data, and the next test data, all the 10 columns, and 11th column is not available. That's why I included 11th column, and I combined both the data. And after combining the both data, I'm observing the data is properly inserted or not. And next, I'm doing any other. Let's proceed to the categorical variable now. During exploration, we see some mismatch levels in variables which need to be corrected. For example, I told that there is some fat content is there in this column. Fat content have only 2 levels, low level or regular. So low and regular instead of a character. I already told in the data analytics, for our convenience. So if you have a male and female, we'll write 0 and 1. Here in the fat content, we have only low and high regular. We'll write it in numerical values for this size. So the numerical for the command above, I assigned the name other as unnamed outlet size variable. Rest I will simply rename the variables item fat content. So you understood here what I was done here. So here what I was here for our convenience, fat content, item fat content, I changed LF and low fat, and REZ is the regular. Next, look at the data set. Ask yourself which factor could influence the item outlet sales. Just now we have discussed in the out of 11 columns, which factor could influence item outlet sales. Anyway, answer is below, but I want you try to out first before scrolling down. Count outlet identifier. There are the 10 unique outlets in the data. The variable will give the information count of outlets in the data set. More of the number of counts in outlet, the chances are more will be the sales contributed by it. For example, there is one library is available, that is the library DPLYR. So you combine a group by outlet identifier. So write a head of A. Source local data frame. I am writing the same thing. So you see outlet 10, 925, like this. Outlet 13 is 1553. Outlet 17, 1543. Outlet 18, 1546. Outlet 19, 880. Outlet 27. So names. So the combine, a join, a the outlet identifier. These are the outlet identifiers are combining. As you can see, DPLY package makes the data manipulation is quite effectiveness. The code above, I will simply store a new data frame in a variable A. Later, a new column outlet is added as the original combination data set. So here, outlet set, we are combining both the things. And count of item identifier. Simply, we can compute count of item identifier too. It is a good practice to fetch more information from unique ID, a variable using this count. This will help us to understand which outlet has a maximum frequency. The combined group identifier and tally. So names and head. So you DRA 12, DRA 24, 10, DRA 59, 10. These are observe. I'll merge these two things. Next is outlet years. This is the variable represents information existence of the particular outlet since 2013. So there is a various years are there. So this is the year of establishment of each outlet and outlet establishment and outlet year. So this is the combination of full join. See, we are joining with this. The suggests that outlets established in 1999 were 14 years old and is in 2013 and so on. So next is the item type. So here important thing, pay attention to the item identifier, which look carefully. There is a pattern in the identifier starting with FD, DR and NC. Now check the corresponding item types to those identifiers in the data set. You will discover items corresponding to DR mostly stable. The items corresponding to ED are drinks, and items corresponding to NC are the products which cannot be consumed. In this called non-consumers. These are the variables and new variables represent their count. Here we'll use substring and G sub functions extract rename variables expression. So here I'm extracting drinks, food and non-consumers. We are extracting here this. Let's now add this information or data set with the variable item. Item type is new. So for example, if you see here in this slide, food and vegetables and snacks and foods are sales are more. And here in the data set, if you observe, there is some sales here. Here 07 and 019, if you observe, item visibilities are 0. This is, we are talking about the item type is fruits and household. These are the things we are exploring here. We are substringing. Here if you observe, label encoding and one heart encoding we have to do here. There is two words. It is nothing new. Label encoding is simple words. In the practice of numerical encoding, replacing different labels of categorical variables. For example, in our data set, I already told item fat count as 2 levels, low fat and regular. We'll encode low fat as 0 and regular as 1. So for our analysis, so we want to replace with strings with numerical values. This is, we'll call it as the encoding. So there's some encoding, a hot encoding we have to do, label encoding. Now low fat and regular. So we will encode low fat is 0, regular 1. This will help convert factor variable in numerical variable. This can be simply done using if-else statement in R. Combine an item underscore fat underscore content if-else. There is a generally, if you want to write control statements, then 0 and 1 is useful. That's why I'm changing this. Next one is the hot encoding. In simple words, is a splitting a categorical variable into unique label and eventually removing the original variable from the data set. So don't confuse. Here I'm example. Let's take any categorical variable, say outlet location type. It has 3 levels. One is encoding of this variable will create 3 different variables, ones and zeros. This representing existing of variable zeros and will represent a non-existence of the variable. So look at the simple, a simple select combination of outlet location type. So here again, if you go to the table data, outlet location, there is the grocery store and the supermarket, and there is a outlet type. There's a 2 or 3 types are there. That's why. So I'm changing this into numerical values. Outlet location tier 1, outlet location tier 2, outlet location tier 3. There is a tier 1, tier 2, tier 3. I replace it with numerical values. So next is the model.matrix creates a matrix of encoded variables. and this is nearly 1 minus 1 encodes all the variables in the data frame, but suppress the intercept. So what will happen if you do not write minus 1? Model matrix will skip the first level of factor, creating results just 2 out of 3 factor levels, loss of information. There was a demonstration of one hot encoding. Hope you understood the concept now. Let's now apply this technique to all categorical variable in data set, including ID variable. So I have included another library, dummies, and combine dummies.data.frame, where here with this I have shared 2 different methods performing one art encoding in R, and let's check the encoding has been done. So this is that we are checking again str combi. This combi name, it is the combined data set of train and set. We already combined train and test data as a name combi. The combi is the data set contains both train data and test data, and later in using some methods, so label encoding and auto encoding, I am converting some textual data into the numerical values and coded values for further analysis. Finally, I am coming to the predictive modeling using machine learning. Up to now, I am doing some data manipulation and data cleaning. Finally, we will drop the columns which have either been converted using other variables or identifiers. So here what I was done, what we have to do, in the table we already converted something. So automatically we have to drop out existing data with replaced data. So combi select combi underscore C, item identifier, item outer identifier, and item fat content, outlet, establishment year, item type, and these are the we are included in the combi database data set. In this section, we'll cover the in future we'll cover regression, decision trees, random forest, and detailed explanation of these algorithms outsets. These algorithms has been satisfactorily explanation in previous articles. I have provided links to useful information also. So here I am taking about the new train data and new test data from these columns. So now I am going to the linear regression model. So here linear regression model. So in the linear regression model, multiple regression is used when response variable is continuous nature and predictors are many. As it went categorical, we would have used the logical regression. So I don't want to discuss about the linear regression in detail, but there is a exist of linear relationship between the response and predictor variable. Here, important thing, generally linear regression models depends on the 2 variables. One is the depending variable and the independent variable. Here, response is the indicator independent variable and predictor is the dependent variable. So predictor is an independent variable are not correlated with each other. The presence of collinearity leads to the phenomenon known multicollinearity. The error items are uncorrelated. Otherwise, it leads to autocorrelation. Error terms must be constant variable, and non-constant variable leads to the heterogeneity. Let us now build first regression model on this data set. And R uses LM, linear regression function LM. A linear model LM I am applied on. So because the 2 important things, one is the predictor and response. All 11 columns I included in the new trained data set, and the 12th column, that is a predictor outcome, item outlet sales, I am comparing with a new data. Summary I am presenting in the linear model. So here first I observed the adjusted R square value. R square value is important for the regression model. R square value should be high. If R square value is low, that indicates something is wrong. So here in this regression model, in our model, R square value we got 0.2085. It means that we really did something drastically wrong. Let's figure out, because first I applied the regression model without doing any modifications in the existing data. I applied a regression model because I'm not yet identified which factors are influencing more on the sets. In our case, we could find new variables or is not helping much. This item count, outlet count, and item type new. Neither of these variables are significant. Significant variables are denoted with star. Now correlated predictor variable brings now model accuracy. Let's find out amount of correlation present in predictor variable. So we'll correlate with a new train data. So here, alternatively, you can also use correlated plot package, some fancy correlation plots. Scrolling through a long list of correlation coefficients, I could define the correlation coefficient. So here, I was verified the correlation between a new train data set, outlet count versus outlet type grocery store. Two variables I observed the correlation. 0.99 again. Outlet count is highly correlated negatively because the minus 0.99 with outlet type grocery store. Here some problems I could find this model because why we got R square value 0.02, that we have to identify. Immediately we have to observe the correlation factor. Once you observe the correlation factor between outlet count versus outlet type grocery store, so correlation factor we got minus 0.99. So automatically some problem. We have correlated predictor variables. So we did one hard encoding and label encoding. That not necessary, since linear regression handles categorical variable by creating dummy variables intrinsically. The new variable, the item count, outlet count, item type new, created future engineering, not significant. So I created a new one. Let's try to create a more robust regression model. That time I will building a simple model without encoding new features. Below the entire code, the path I am writing, I am taking the only February data sets and again train data. So I am taking your test data and combining train data, set data, and impute the missing values and compute item visibility. Here I am observing the various things. Fitted values with residuals values fitting, normal, and theoretical quantiles. Here I am including a linear regression model, and I've included new column in 2013 and drop variables not required in this model. Here, if you observe, first is the rename level in the outlet size. Outlet size I am renaming and rename levels of fat content, and these are the things I am modifying. Create a new column 2013 year and drop variables not required for the modeling, and divide data set into new train and new data, and apply linear regression model on outlet and new train data, and R square value now it is increased 0.56. So with this new modifications, so what we are observed and we are applied, the automatically R square value is increased. This teaches us something. All you need simple thought process, get a high accuracy, a quite good improvement of the previous data model. Next time you work any model, always remember to start with a simple model. So here I am writing some outlets. You can zoom in the graph, your R Studio, you can add. All these plots have a different story, but most of the important story being prepared residuals and fitting graph. Residual values are different between the actual and predicted outcome values, and fitted values are predicted values. You see the carefully, you will discover its funnel shape graph, and the shape of this graph suggested that our model is suffering from heterogeneity, and unequal variables in equal terms. Had there is a constant variables, there would be no pattern visible in this graph. A common factor to tackle heterogeneity is by taking a log response of variable. Let's do check if you get further improvement, because in this model, for example, in the linear model, item outlet sales, and you apply new linear train data, then the snapshot of the my model output, we got R square value is a 0.72. Now we are in the right approach. Once again, we check residual plots. You might zoom in, you can find out the variation. Here, if you observe residual, so more values 5 to 9. If you observe the previous residual, in the minus values we are removed and we are going to the positive values. We got this model future improved, deducting and outliers, high leverage points. Now use this. So this apply, we can use the decision trees and random forest. I don't want to cover because we are going to the in-depth of these things. I'll give in my website, I'll give the PowerPoint presentation. You apply random forest methods, and because I was seen only linear model, because little bit complexity included. That's why I'm not discussing here decision tree and random forest. You can apply at your home and you can implement, because the total data is available. And one more example I want to show here. Nowadays, everyone knows the COVID data. So using analysis, data analysis or data analytics for COVID. So these are the packages we can use. And I'm taking the data. See here, I was given a link, a github.com. And there is a COVID-19 India data is available. This data we can do analysis. So here I'm telling same thing in same way. We can apply the models. Here I was done some modeling. You take the columns because I can show the data items. Here you see everyone knows COVID data. So what are the data? Day by date. First we got in the December 19. The data is COVID data. COVID virus started in India. Now it is the July 17th. We got we are crossing the 10 lakhs, nearly more than 1 million cases. So if you take the total cases and daily wise cases, cured cases, total deaths. So like this, there is a various columns are available. You just download the data from your R Studio, and here you take what are the columns you require. Simply you take a data and you take only required columns into database, and in this required database, so you apply simple plot techniques. I don't want to discuss more and more analysis. So you know you go to the website and you observe a simple plot or ggplot2, how to use, and you study the syntax, and you apply x-axis date on x-axis, and in the y-axis total cases and daily cases and total deaths and cured cases. So just to see the graphs like this, visualization, number of cases, I wrote here the count, deaths are increasing, cured cases are increasing, and so in the various countries, how the data will be good. This is the current confirmed cases. Here I was taking the data of China. China cases up to May, the cases are increased, the latter is decreases. So here, in a similar way, so the deaths are increasing. You observe a lot of code. So if you want, I will provide the code is also in my website. You can visit my website, varmaps.com. You can see my PPTs and code. The first thing, so you go to the data. You go to the data and you download and you write it in the column wise. And after that, what we have to do? That is an important thing. Data analytics for the COVID data. So really, if you want to predict something when it is ends, it is very difficult to predict because the data is still not complete. Because whenever we are collecting the COVID data here, so we have only affected cases, cured cases, but we are not yet included the environmental conditions and age group and the person's health conditions and the people who are recovering and what are the symptoms are more, which symptoms we can recover, which symptoms are it is not possible to recover, and who, inside the body if there is any health problems on a particular person, in which health problems it is increasing the COVID inside the body. There's a lot of studies data, still it is not available. That's why I'm not included the data analytics of COVID data, only data analysis, because you have to find the difference between the data analysis and data analytics. Data analytics, so we have studied the big marked data. Once if you observe any marked data, how to increase the sales. So in the dependent variables, what are the variables is depending on the sales, that variables. So here in our example, we are seeing the data visibility. So if you increase the visibility, the sales are increases. For example, when you are going to the any mall like Big Bazaar or Walmart or DMart, so whenever we are entering into the shop, which items we have to keep in the initial stage and which items where we have to keep, these are the outcomes. Because whenever you enter into the any shop, the goods which are less sales we have to keep in the initial place, because in the when you enter the shop, if you keep the items which are sales more, then all people will gather at the initial place. So that indicates only the say which items are having less sales will keep in the front first face of the shop, because only few people will stand here and the people move in the forward direction, and the items which have a more sales, you don't keep in a single place, you in a distributed place, because that's that analysis, that analytics will do with the analysis of the products and sales. But if you observe the COVID, we require in this initial stage to do the analytics, and you can do the analysis. And nowadays it is one of the prime area for doing a research in this area. So everyone, so you can work in this direction to do the research. And I'm stopping here. If you have any queries, and you can write to email professorvarma@aknu.edu.in, or you can visit my website. And I'm just I request one of the organizer could come and end the session. So in my website, I will provide PowerPoint slides and R code also. You can try at your home. I am giving line by line explanation how to execute in the R Studio.
Yeah, good afternoon, to all the participants and uh, our renowned orator today, Suresh Varma garu. I'm going to present vote of thanks. This is SURESH, HOD Sanketika Vidya Parishad Engineering College. I would first of all like to thank Dr. Ramji garu and Professor Suresh Varma garu for having such a wonderful session. We could see the number of participants, jubilant questions and other things. It was wonderful. But I thought the time was so limited that the time just passed away 1 hour, 10 minutes, 1 hour, 15 minutes. I think it could have been more also. I can understand the pain the resource persons take from the other end to explain all the things with the PPTs and the current situation and other things. I would like to thank the management, Dr. SVH Rajendra Garu, Secretary and Correspondent, all others group of institutions. Surely, sir, I would like to again conduct one more session if possible from your end, if given a chance. Suresh Varma garu, it was wonderful that you have even connected the recent COVID analysis and other things. We were very happy to see that. Uh, Finally, I was able to find out how analytics could help. Really, it was wonderful at the end that you said that something that sales, the less number of sales would be in the front. I never thought in this way. I was only part and parcel of if bread is available, jam should be available nearby. I never thought of this situation. So this was wonderful in real time. You can understand how you could connect to the real time. Your experience shows how it carries on. We would really like to get some more resources from your website also, sir. Thank you once again for a wonderful session. You could see that from the participants' feedback. Thank you all the participants for making it so successful. But before we end up, I would like to thank my whole team of CSC, Ravindra Babagar, who was the coordinator, and Anil, who was back end of the participants and other things. Before I conclude other things, before thanking the other things, I would like to mention a few points. All the official information will be provided only in WhatsApp group, those who have registered. And before that, information form also is provided to you from today till tomorrow morning 10 o'clock. It is available in your WhatsApp group. Whatever information you are providing in the information form will be reflected in your certificate. So your names and other information that you are filling should be very clear, should not contain any mistakes. I expect that your information form hardly it will take 1 minute or 2 minutes to complete. Till tomorrow 10 o'clock it is open. So kindly fill the information form to get a valid certificate. You will get a certificate within 1 week on or before 25th of July, that is next Saturday. This being a government certified one, certificate downloaded from your DigiLocker. So it doesn't come in your email. It doesn't get shared in your WhatsApp. All this is only downloadable from DigiLocker. So it's a different way of getting your certificates because it is government certified. I again repeat, all the names and information that you provide in information form is final. So take every step that your names are clearly given, your organization names are clearly mentioned. Any other mistakes, we cannot help it with. So fill your information form very clearly. Once again, I thank Professor Suresh Varma garu for his valuable time for this session. Sir, we would like to have one more session. I don't know when it is possible from your end. Really wonderful to see your passion and other things.
One important thing, next
Yes.
time, not like this. If you have an interaction, continuous interaction,
Yes,
then
sir.
I will explain through our software directly, because that should be a limited persons, 25 to 30, and
Yes, sir.
everyone should acquaint. And I want to verify online their videos also, because
Sure, sir.
they are learning or not. That is the important thing, because in this one way, because I can show the R Studio, but most of the people will feel they will not be happy, because it takes time. Because whenever I'm executing, and they also ask to execute, to download, and that should be like a lab section, iLab. It
Yes,
is
sir.
not,
Yes, sir.
because then only they can understand, they can enjoy the analytics.
Yes.
Otherwise, the PPT is they can understand the concept, but they cannot enjoy the programming, coding.
Yes, sir. Yes, sir. As cases are growing, and we thought it would be fine for 1 or 1.5 hour. You made it between 1 to 1.5 hour. I understand your valuable time. Surely, sir, because with your timing that is possible, we'll surely go ahead and plan another webinar, say like 3 or 4 days.
Time is not in I can have a time, but the
Yes,
people have an interest, because if I extend 1 more hour, most of the people will leave because the
yes, sir.
lunchtime.
Yes,
If it's a selected group 25 to 30, and slowly I will teach using R Studio. If they have any doubt, if they able to question, and I will able to rectify on the system, then that will be useful to all.
sure, sir. Sure. We'll go for an interactive session as you have mentioned, sir. Surely we'll go on, sir. This month end or next month, we'll surely plan one more, sir. The
Okay, sir.
continuation of this. Thank you, sir. Thank you so much. Thank you all the participants with whom we could do this session. Thank you, one and all. Thank you.
Okay.